Alrighty, in this video, what we're going to do is talk about one of the most important files when working with Node and NPM, and that is going to be the package.json file. Basically, the first thing I showed you guys was installing things globally. Then I showed you guys how to install things locally into a Node modules folder. But typically speaking, we need to actually go one step further if we actually want to make this a well-behaving project. And the reason for that is Node modules is not something you want to commit to source control. Node modules gets very, very big, very messy, with a lot of files. You don't want it anywhere near your repository. In fact, even if you're not using source control, which I hope all of you guys are, but even if you're not, and you need to move a Node project around, maybe FTP it up to a server or zip it up for archival purposes since you're not using source control and, I don't really know what people who don't use source control do. If you do one of those things that you do, then you're not going to want to include the Node modules. The Node modules is very big and very messy. So how do we get around that? The answer to that is we create a little JSON file in the root of our project that tells NPM what packages we want and what versions we want them of. So that's what we're going to be talking about in this video, package.json. So like I said, this is going to be the first step you do whenever you start a project. And it doesn't matter if you're creating an application in Node or using this as your build tool. Get to your root of your project, likely where your gitignore is, or maybe under a source directory or something like that, but preferably in the root of your project. Get there and type in this command, npm init. Now, npm init is going to walk us through the major attributes of the project.json file and actually generate one for us. So I'm going to go ahead and hit npm init, and so it's going to ask me a bunch of questions. So the defaults are going to be in parentheses, hit enter to get the default. And the first thing it asks me is it wants a name. It needs a package name. Technically, we're creating a Node package right now, but I say that in a very general sense. We're not necessarily creating a package that we're going to upload to npm.js.org, although you might be, but we're creating an actual Node package. And for the name, I don't really like that name because 03, I don't like numbers in front of my package name, so I'm going to go ahead and just say example1. There we go. Hit enter. Next up is the version. Now, we're going to be talking about versions later. Versions are incredibly, incredibly important, but we're not too concerned about them at the moment. So stuff and things, the version number will be a lot more important if you're writing a Node package. They'll be pretty important if you're writing a Node application, and they'll be 100% irrelevant if you're just using Node as a build tool. So in this case, I don't really care about this. We're not talking about versions yet, so I'm just going to hit enter to accept the default. Next up, we have a description. Really doesn't matter unless you're going to be publishing to a Node package repository because it helps with search. So in this case, I'll type something in just because this is an example project. But it really, really doesn't matter if you're writing a Node application or if you're writing if you're just using Node as a build tool. Next up, entry point. So this is something I've been alluding to for pretty much the entire series so far. Every time I hit node dot or type in node dot or I require in a Node directory, it defaults to searching for an index.js. We've seen this behavior a lot. This is where you redefine it. You set a different entry point. In this case, I'm going to leave index.js as the default because I want to have an example of editing the project.json file later in this video. So I'm just going to hit enter, and we'll talk about this more in a moment. Test commands. We're not talking about test commands yet, or commands in general. NPM has this weird little pseudo script execution engine thingy, and I'm going to be covering it, but it's not something that we're going to use a whole lot in this series. So in this case, I'm just going to leave test command as blank. Git repository, fairly self-explanatory. This is very useful for open source projects, especially projects that you publish to NPM. This is just going to be the HTTPS or Git URL to your open source public Git repository, or private closed source local internal Git repository if you want. But it's just used as additional metadata for displaying on npm.js.org. We're not worried about that, so let's just go ahead and hit enter. I do want to point out, though, A lot of times when you start a project, you're not going to already have a Git repository set up, so you won't have a URL to put in here, but you can always go back in your project.json and change this at any time. Keywords. Keywords are just useful for basically for NPM.js or other NPM sources, so I don't really care about that for this project. I'll hit enter. Author, very self-explanatory. License, also very self-explanatory. Pick whatever license you want. Please always include a license with your code. ISC is a very, very simple, permissive open source license. There's also a million other licenses you can choose from. There's a website dedicated to comparing and contrasting all the different open source licenses that are available. ISC is fine for our purposes. Okay, so now it's going to give us a preview of the JSON file it's about to write. Which looks good. I'm going to hit yes just so we can take a look at this JSON file in our editor with colorization. Okay, so basically all that did was it created a package.json file in our root, in the directory that we were in our command line or terminal, and it just wrote out basically verbatim, almost verbatim, all the stuff that we gave it. Our name, version, description, our main script, our scripts, which I'm just going to nuke this entire thing. We're talking about that in a later video. Author and license. So, fun stuff. Let's go ahead and really quickly talk about main. I really want to discuss main and show you guys how it works. So right now main is index.js. So I can go ahead and create, which is the default by the way. If I didn't specify a main, it would still be index.js. So if I come in here and write index.js and say console log hello from index, and then come over here and type in node dot, we'll just get the exact same behavior that we've been seeing in the entire series because we didn't change any default. Now let's go ahead and change that, because sometimes we don't want index.js to be our default. And I'll show you guys an example later in this video of a case where that's not, a case where changing this is actually incredibly appropriate. So let's change this to server.js. Now there's going to be something people paying attention will know that I did not create a server.js file. And I didn't for the purpose of just demonstrating a particular behavior of how the main property works. So what do you think the output is going to be when I hit node dot? Well, the answer to that is hello from index. It seems that nothing changed. You would expect there to be an error saying server doesn't exist, blah, blah, blah. Well, the reason for this behavior is that if the main file exists, it'll use that. If the main file does not exist, it'll default back to the default index.js. So we can go ahead and here, to prove that's the case, create a server.js and say console log from server. That's not how you spell server. That is. Now I can hit node dot and check that out. Now we're getting our from server message indicating that our server.js file was indeed loaded and executed. All right. So that's our package.json file, a really simple one. So far, it's not doing anything useful. So let's go ahead and change that. There's a handful of ways of using package.json to pull down node modules. Again, the biggest point I'm trying to make here is, yeah, there's a lot of other useful things in package.json, especially if you're, well, absolutely required if you're writing a Node.js package, and especially if you're doing a Node.js application, but not so much if you're doing if you're using Node as a build tool. But there's some really, really important properties here, and they all boil down to using package.json to describe the dependencies that our application requires, so that when I pull a project down from source control onto my computer, I can type in one command and get all of those dependencies rehydrated into my project without having to add node modules to my source control. So let's see an example of that. There's going to be two ways that we can add packages to package.json. I'm going to show you guys first the simplest way and the way that I recommend most people go about doing this. I can come in here, I can type in NPM install, let's install, I don't know, moment. Now I'm not going to hit enter yet. So this is what we would do before. We know what's going to happen when we do this. We type in npm install moment. We are going to get a node modules folder. Moment's going to be pulled down and installed there. But nothing else is going to happen. If I instead pass in -- save and hit enter, something interesting is going to happen. Moment got pulled down. A node modules folder got created. But inside the package.json file, we now have a dependencies attribute that describes all of the packages that are required by our project. So this is incredibly important. This is really the biggest point that I'm trying to make about using package.json. Now, ignore the version number here. We're not talking about version numbers in this video. We'll talk about them later. So ignore that for now. So what's the consequence of having dependencies in our package.json? Well, let's go ahead and simulate pulling this project down from source control. To do that, I'm going to go ahead and open up my file explorer to this project. And basically, let's just pretend that we have a Git repository and we have a git ignore file in here. And our git ignore file is ignoring node modules, meaning this folder is not pushed up to our source control and is not pulled back down. So let's simulate having just cloned this non-existent fake repository by deleting node modules entirely. So you just did a git clone, and these are the 3 files you got, right? Well, obviously our code's not going to work right. If I come into server.js and say var moment equals require moment, and then I say console log moment.format, if I come in here and hit node dot, obviously we're going to get an error. Cannot find module moment, because it's not installed locally, and it's certainly not installed globally, and it's certainly not installed on any of the parent directories of my current folder. So how do we fix that? Well, since it's in package.json, we can instruct NPM to go out and download everything that's listed in our dependencies. So I can say npm install. Hit enter. npm install will take a look at our package.json and actually go out and locally install that package. So now I can say npm list, and as you see right here, moment is listed. Whereas I'm going to delete my node modules again. If we did npm list here, notice how we get an error saying unmet dependency. So again, I should have shown the npm list before I deleted the node modules the first time, but I did just delete npm modules again just to show you guys, if you do npm list and you have a package.json file, it will warn you if there are dependencies that don't exist. All right, let's go ahead and npm install again real fast. Now that package is installed, I can hit node dot, and indeed, we do get the time. Right there, for a moment. Moment's a brilliant date time handling library. I highly recommend you guys check it out. Anyway, so that's the dependencies, and that's the power of the dependencies. We can just describe what we want, hit npm install, and we get everything downloaded for us locally. Very, very, very handy, because like I said, node modules is going to get very, very, very big. And you do not want that being copied around. You don't want that being FTP'd around. You don't want that being zipped up. And you certainly don't want that being pushed to source control. All right, so I said that's one way to install dependencies. There is another. I can come up right here into package.json, and I can just edit it directly. I can come in here and type in, let's say we want Lodash. Now, do check this out. This is one of my favorite features of Visual Studio Code. It's also a feature in Visual Studio 2015 if you have the Node tools installed as well, but we're going to be talking about 2015 Visual Studio later. So I do get code completion against the actual NPM repository, which is a big help. But if you don't get code completion, that's fine. You can just come in here, type in Lodash, and then let's say what version we want. In this case, I could also do code complete, but instead I'm just going to go ahead and grab 3.10.1, which is the latest version. Again, we're going to talk about the version numbers and what this funny little caret symbol means later. Now we can come back here, and you'll notice that it won't automatically do anything by pulling in this dependency. Now, that's not necessarily true for your editor. If you're using Visual Studio 2015, simply by editing your package.json file, Visual Studio will go out and download this Lodash package into your node modules, which is another awesome feature. Visual Studio Code does not do that, however. Meaning if I come back here and now do npm list, you'll see that I have moment installed, but I have an unmet dependency of Lodash. So now what I can do is simply say npm install, and it'll go out and it'll grab all unmet dependencies. And as you see, it went ahead and downloaded Lodash. It did not reinstall moment, but it did grab the new guy. And now if I do npm list, we see that we have these two packages installed. So that's another way to add dependencies. Some people prefer adding package.json, especially if you have code complete and all that fun stuff. I generally prefer, though, to do npm install save for this. Okay, there's one more thing I want to talk about dependencies in this video, and that is dependencies isn't the only field that you can describe dependencies in. There are also, by the way, Visual Studio Code gives you code complete for package.json as well, which is very nice. It's not the only editor to do that, of course, but stuff and things. I hope I'm convincing some people to at least try Visual Studio Code out. Anyway, we also have Dev Dependencies, and we have peer dependencies, and we have bundle dependencies, but I don't want to get into that. Okay, so Dev Dependencies and peer dependencies work and behave exactly like dependencies, but there's a big difference. A dev dependency, for example, if I said I had a dev dependency on, I don't know, jQuery, well, that's kind of weird. I don't know, Gulp. Gulp is a good one to have a dev dependency on, and let's just do 391 or 390. So if I have a dev dependency on Gulp, what happens is npm install will only ever install this dependency if this package is in the same directory as where we're executing npm install from. Well, actually, let me go ahead and show you guys an example of that we can actually take a look at within the modules that we have installed. So remember, I guess I'm going to go ahead, I'll nuke out Gulp, and I'll just remind you guys what happens, when we install React, for example. So I'm doing npm install React save. Always make sure you do the -- save. But I pulled down React. React pulled down all of these dependencies, right? That's because in React, where are you? In React, it has these two dependencies, and then these two dependencies have dependencies of their own, and those dependencies have dependencies and all that fun stuff. In React, we don't have any dev dependencies, so I can't show off that in this context. But I want to point out that when dependencies of another package are installed, when a package with dependencies is installed, the things listed in dependencies is as well. So what about dev dependencies? Well, there's a great example in Moment. So if I open up Moment and open up package.json, notice how dependencies, where are you? Dependencies. Dependencies is blank for Moment, which makes sense because if we do npm list, we don't see anything under Moment. There's no dependencies, no runtime dependencies. So to run Moment, you don't need anything else. But check this out. Its dev dependencies is loaded with stuff. And again, this the dev dependencies behaves exactly like dependencies as far as the syntax, name of module followed by version of module, but these aren't installed. Now, the reason these aren't installed is these are only installed if, I guess the way to think about it is if npm is thinking that you're actually developing on this project. So if you need additional tools to do development on this project, and it's not going to install those dependencies unless we pass in a special flag into npm, or we execute npm install from within this directory. So again, if I come in here on dev dependencies and pass in jQuery, and install jQuery, and then I do npm install, notice how jQuery does get installed. But if this package was included by another package, the dev dependencies would not be installed because dev dependencies are only for development purposes. Kind of comes in the name. So, yeah, that's dev dependencies. Typically speaking, if you're using Node.js for building, for processing, but you're using another framework like ASP.NET or Ruby or PHP to actually do your application with, all of your dependencies will be dev dependencies. Now, a way to use npm install and get it saved into dev dependencies is save dev. So I can say npm install gulp --save -dev, and it has the same behavior as save. The only difference is it's going to jump in or go into dev dependencies instead of dependencies. So as you see, gulp did appear and was written in by npm. Peer dependencies are kind of like optional dependencies, but the thing about peer dependencies is There are things that won't be installed. If a package says it has a peer dependency, that dependency won't be automatically installed. It's a dependency that you as the person consuming the other package needs to provide in some way. You can kind of think of it like a sideways dependency. That pretty much wraps up this video. And in the next video, we'll talk about versioning. So we'll see you guys then.